Good morning everyone and welcome back. So a bit of an interesting day today, but 6 months ago Johan came out and we did those EDNA samples, which just means we were testing the water for the DNA to see what's in it, and the results have come back. So Craig's come out today, and what's your job, Craig? I don't want to say it because I'll probably get it wrong.
No, Principal Scientist Freshwater at DairyNZ.
So Craig's come out to answer a few questions, talk through the results a little bit, and let you know, or let me know what's going on. But yeah, it's pretty cool. I have seen them online. They're not public yet, but we're going to make them public. So if you want to go and have a look, you just go to Wilder Lab and sort of go to the area where I am and you can see it.
This is where we took it, right down in here.
Yep.
It was in the shade under these trees.
Yep, I jumped down here. Oh, there's a few ducks down there. So I put one of the samples just in the water down there.
Am I going to sink past my little gumboots?
Maybe, it might be a bit sedimenty.
Oh, man, that's for the video already, look at that.
Yeah.
But it's,
you need longer gummies.
yeah, no. I see why you don't use your red bands, although I think that was going to be endangering. But it was, I've got to drive to Northland in these jeans now. Yeah, but it's still pretty cool how you know, just like in here, you're probably at that sort of 70% shade.
Yeah.
Under here, and so you got no or very little sort of macrophyte weed growth in the stream.
Yeah, yeah,
And,
definitely.
whereas down there, it just gets, you know, in the sun, it gets choked up. So if you can sort of, this just sort of shows you that science of shade.
The weeds, they're, besides shade, it's cooling the water. It's also holding the banks together. But when the weeds are in there, they're sucking up and down the oxygen within the water.
Oh yeah.
Fish need oxygen.
Well,
Yeah.
even in here, you know, it should be still pretty shaded, wouldn't it? Because it's,
Yeah, yeah, that hedge has got a lot of shade in there. It's pretty deep.
you don't get me from behind. Looks like I pissed myself. Where's the edge?
Yeah, you might be right on it.
This flows all year round.
Yeah, pretty much.
Yeah?
Yep. Yep, even through summer, like it'll be a little trickle, but yeah, it does. Yep. The sample which was taken over there, so that goes up this drain there to sort of below the cow shed, so it collects all that. And then also where I did the plantings over there, there's a drain that runs down the side here, so it collects both of those tributaries.
These like seeps planted out here?
Yes.
Yeah.
Is that around the corner here, eh?
Yeah, that's the one we did.
Yeah. Pretty cool.
Yeah, no, that planting up there is looking really good. Happy with it. So it's only going to get bigger and look better, I think.
Yeah.
But it's been a year, just over a year, probably 14 months.
And what was the mix that went in then?
Oh, I couldn't tell you. There's about 10 different species. I couldn't tell you though,
Yep.
to be honest. Look at this, Craig's even put a pamphlet together, which is pretty cool.
So we're on this one, aren't we?
Yes, we are. Yep.
Yeah. So yeah, this is where we had the long fin, short fin, that's the gambusia, the little mosquito fish.
Okay, but they're bad.
Yep. So these are the good guys that we found.
Oh yeah.
So we've got long fin tuna, short fin tuna, and like I say, these are on the at risk declining or at risk. They got some threatened species status in New Zealand. So, and typically the long fin, they're generally they sort of like, you know, reasonable sort of water quality. So,
yeah.
so it's still a really cool sign that when you see a long fin. Short fins, like I say, they sort of like it dirty. They can sort of handle.
They'll go anywhere.
Yeah, they can sort of be in, like, they'll be in your farm drains and all that, but you're normally not the long fin. So the fact that we see long fin tuna here is pretty cool. Not at this site here, but at the wherever this site here.
The other one, the other one, which is straight through there.
Yeah, and that's where you've sort of got this little fish here, which is a Cran's bully.
Oh yeah.
And Cran's bullies are pretty cool because a lot of our fish do, probably in the Waikato, I don't know, most of our fish will head out to sea. They're sort of migratory, like the whitebait runs. You know, you sort of get, so the whitebait run normally is comprised of 5 fish. 3 of them are actually threatened species that we eat. so you know, the giant kokopoo, I think the short jaw kokopoo, and guaro, EDNA, and there's another one as well. But they're all galaxid species that are part of their, you know, their sort of reproductive cycle. They'll have a freshwater phase, but then they'll either head out, sort of like EDNA, they'll head out and spawn near the coast.
Oh yeah.
Or if it's like some of the other fish, they'll be they'll actually spawn in the streams, and then when they hatch, then the little hatchlings sort of swim on out to the coast.
Yeah.
And then they'll stay out there for, I can't remember how much it is, a year, 18 months or something. Then those guys come back up. And
They
so
come back to spawn, or they come back to live?
Come back to live.
Oh, right,
Yep.
okay. Oh, yeah. That's
And,
pretty interesting.
And then eels are they're the ones that can actually, you know, if you're like in this stream just here, it's a small stream, although it's quite deep.
In places.
but it's, except those long fins, they can, you know, on the average, they sort of say they only make one trip, so they're on a one-way trip when they leave, sort of thing.
So they spawn over in.
Yeah, they think it's over in Tonga somewhere, but it's way out. So it's and they only do that once, so it's a one-way ticket. They don't
So once
come back.
they spawn, they die.
Yep.
Yeah.
And then I think and then those sort of glass eels or whatever that hatch, they kind of drift back on currents, and somehow I guess it's like Finding Nemo, you know, they get the right.
Oh, I think it's a like amazing nature, because the spring or the young offspring from those eels come back to, they say, the same same tributaries that their parents did.
And they'll cruise up to Port Waikato, I guess. That's the only way in.
Yeah, I guess.
And we're a long way, you know. It's coming up the Waikato, up the Waipa.
Yeah, we're on the wrong coast even. I didn't even think of that. But yeah, Port Waikato's on the west coast, and Tonga's out that way. So far out.
So it's and then they sort of come up here, and long fins especially, really, really good climbers, so they can get way inland. I'm not sure what our elevation is here, not that high, but still, that's if there's little dams or waterfalls, they can still come in here. But it is still pretty cool, because on average, I think they'll still be here they can still live on your farm and be in part of your environment here for 25 to 50 years, you know, sort of thing. So as long as you've been a little kid growing up, you could have had a long fin eel here.
Well, that was going to be my next question, actually. At what age do those eels go to Tonga to spawn? Well, they'd be quite old when they do that, if they're going to die. I
think it varies. You know, when you see, we saw that large eel, the largest eel I've seen in a little while was that one you saw around Tokoro and the Whakaudu, and that was about, what was that, 1.3 metres, 7 kilo, and they reckon that was probably 30 years old.
Oh, right.
Yeah, but then the ones you can see that are really big, you know, the ones that you see pictures of, sort of thing.
Great breeding
Those are
stock.
the ones that can sometimes be up to 80 years before they head out.
Gee, that's crazy, eh? So moving on to the tests, how about water quality? What do they come back at?
Oh, the water quality. So in terms of, that's the beauty of this. I mean, it's you know, water quality, what are you measuring, and then often what's in those streams, if it's nitrogen or if it's sediment. It's actually, the science isn't as good as we think for linking that to effects. So while they can potentially be you know, causing trouble for the things that are in the stream, what we're trying to focus on now, I guess, with EDNA is actually, when people want a healthy stream, what is a healthy stream? Is it a decimal place of nitrate, you know? And so if it is, then does success look like if you go from 1.67 to 1.29, is that success? Or is it actually knowing that the stream is actually sort of allowing these long-lived species to actually live in these sort of streams? And so that's why, like in this stream here, I think you've got a picture of it before, but you know, it's a small stream, but you know, you've got longfin tuna and shortfin tuna living in the stream, you know, long-lived species, and at the top of the food web. So if they're in there, and they're obviously sort of eating macroinvertebrates or eating things, so if they're in there living, there must be enough food in there. So that's why we sort of tried to move a little bit away from, if what's in there is in there, then you know, or how can we make that sort of habitat or environment better? So rather than looking at concentrations of, you know, nitrate or phosphorus, those things will still be important, and as farmers and that we're still, well, I'm not a farmer, but we're still always trying to sort of through good farming practices and just doing things, you know, looking to sort of minimize the loss of those. But we're really focusing on EDNA is just letting us know what's in the stream, and it looks, so as well as fish, which is only 2 fish, but it also picks up about 400 different bloody things, you know, and this is it's pretty hard to see.
Yeah, there's a wagon wheel.
Yeah, there's sort of this wagon wheel with all these, so there's hundreds of things in there, and that's right down to even bacteria and all these things that I don't even know about. And then, but then what the, I guess the clever people then try and work out is, how does that sort of translate into a stream health number? So if that's, you know, in terms of, so we've got our fish species, but in terms of a stream health, and this is actually, if we had just tweaked it a little bit more, you would have got a good, but you're on average. So that's, you know, in terms of, oh, there it is there, see?
Oh, there is a little graph.
Yep, so you're average, and see if you hit this 100 here, if you're 98, but if you're at 100, then it swaps into good, you know, sort of thing. But this is, I mean, this catchment we're standing in, I think it has less than 1% native land cover, and that's a real big, you know, how much you modify a catchment from native bush obviously has an impact, you know, because we're starting to do things, humans, and we make changes. And so just like we've obviously vastly changed the biodiversity of, you know, terrestrial. This was a forest, or kahikatea forest, it's not now, so the stream will change, but it's but in saying that, you know, we've still got these you know, we've got long finials, short finials living in this one. Over at the other one over there, we've even got bullies that are non-migratory species.
Should we go for a walk over there?
Yeah, so
I don't think it's too far to walk, is it?
Yeah, good, I reckon. Eh?
Might dry your pants out if you got a bit of a breeze behind you. But ideally, in the future, we're going to just move the fence on the other side out. Doesn't have to be much, and we'll get a little bit more space. And then, yeah, plant both sides of this going down. Like, we've got a little bit of space over here. We can't move it heaps, but if we just pull this post in, and just plant some things along here. There's a lot of watercress over here as well.
All these small streams. Yeah, the cabbage
tree combo.
Yeah, like cabbage trees in there to hold the bank back a little bit too. And then just carrots and down by the water, hopefully.
And a variety of carrots. You got germinata as well, and I've got a giant umbrella sedge you could use.
That's the one, giant umbrella sedge. Yeah. You'll actually put some of that in over there. I got a tray of it.
They're really good at holding banks and structures.
Because they're bigger plant, aren't they? They go a lot bigger, so break it up a little bit. But that actually goes to show, like, isn't it amazing that you look down there, weedy, and then just under the trees there, clear. So that shading makes heck of a difference. The only thing that probably isn't good though is just the trees like these that just drop heaps of leaves, and then they sort of just fill the drains up with sledge. So almost need to replace those trees with something more.
It's funny, isn't it? Because even when you have native trees, they do drop the same. They reckon they drop the same amount of leaves, but it's just at different times of the year. Evergreens. Oh yeah. They still renew their leaves. You know, it's like manuka. You know, that's why there's so many leaves all on the ground. So they normally have more drop, I think, during when they're sprouting away in spring or something like that. So, but yeah, no, that's so that magic number that that all that work that NIWA did. They reckon if you have 70% shade, so if you're 70% of when you're looking up there, sort of thing, you got gaps of light. But 70% is the magic number, I think, for controlling temperature and controlling just weedy growth in the stream. So, and then Hawke's Bay Regional Council have actually got a nice shade guide, which I think I put it in here, but it's just these rules of thumb that if you, as much as your stream is wide, if you can have plants as high as the stream is wide, so that normally that's all you kind of sort of need to be
That'll
doing.
Be enough to shade it.
And it actually can include the bank height as well. Because your banks, even your bank height creates shade.
Yeah, definitely.
Around, so
that's actually quite a good rule of thumb, isn't it? It's a nice, easy one. Yeah.
Well, and in terms of buffers, it's always that how long's a piece of string. Certainly in regulation, you know, how much do we need for minimum setbacks? Do we need 1 metre? Do we need, some people will be saying we need 10 metres, you know, sort of thing. And it's like that, you know, if you're sort of thinking about, well, my goal is to sort of you know, have a functional buffer that's going to provide shading to the stream, cooling, stopping the clogging up of things, stabilise the banks, then you can be working in that sort of very small drains like this. You can be doing a lot with 1 to 2 metres.
Yeah.
A lot of that sludge, like you said, 7 years it was cleaned out, but it'll just be that weed build-up.
Yeah, definitely.
It dries down and then you get another layer. And
so yeah, that's the and yeah, like back there, if we can get shade, we can reduce the sediment going forward, or the sludge just from these.
And your cost.
Yeah, and the cost. Don't have to clean it out, which would be nice. We've walked over to the other stream now, and this is where I did the other sample. I'd just done it down in there. It's actually quite a nice looking stream, this one.
Yeah.
Except all these trees, I need to pull all these out. So we are going to redo it, just because they're all sort of dying and falling over now anyway. But they have given a lot of shade.
See, if you had that one there and you had another one here, the two touch.
Yeah.
You have that channel. It'd look like that picture in the book.
Yeah, because that carex, yeah, it would be halfway. It'd be halfway over the stream.
And that one down there, see how it's hanging in the thing? It just creates a bit of a habitat for fish too. So
yeah, true. I never actually planted that. That's just natural, but it's right down there. So yeah, if we plant some up the top here and shades out both sides, it'll be awesome.
Yeah, this stream here, hard bottom, and it's you know, good water clarity as well.
What was the rating for this one?
Oh, this was 98. The other one was 96.
Oh, yeah.
But I mean, these are the same basically, sort of thing. But it's but you know, geez, that's, you know, like I say, 100 would mean you're good. So
yeah, not far off that.
Good.
Yeah. Yeah, plus or minus a couple.
Oh, exactly. Which, like I say, is pretty good when you consider that we're in a highly productive landscape.
Yeah.
With I think it was on the Mungo Tama website or something. One report I was reading anyway. I think it was, they were saying for at least the Lake Naroto catchment, which is about, I think it's about sort of 12 or 1600 hectares of the 7,000 hectares before it goes into the Waipa. But it was it's 0.5% native land cover. So,
Yeah.
So normally, if you're sort of looking at things like aquatic insects, if you were to sort of plot up, you know, look at all your aquatic insect scores, which are a good indication again of sort of stream health, you know, how in a hard bottom stream or something, you know, how many sort of little aquatic insects are in there, like mayflies and caddisflies.
And the more of them, you're going to have more fish too, because they feed on them.
Yeah, although you know, fish ecologist at Niwa, she sort of kind of said that, you know, native fish aren't that fussy, so they sort of even when you sort of start to get more, you know, enriched or, you know, sort of pastoral sort of farms, and you lose those high values or those the things that like really clear water and cobbly streams and all that. So sometimes you move from those to more kind of, you know, wormy snails and that type of sort of thing. Native fish don't care if they eat a caddisfly or a chironomid. All New Zealand fish eat aquatic insects, and so we don't, unlike those pest fish that eat plants, none of our native fish eat plants. They all eat invertebrates. So if there's fish in the stream, then they're obviously eating invertebrates, and there's stuff for them to eat. So that's sort of main thing. Fish are higher in the food web. So if we're measuring and looking at fish in here, and we've got these fish species. So in this stream you're standing in, we've got longfin, shortfin, and Cran's bully.
So that's not a pest fish, the bully?
No, that's a goody fish.
That's a good one.
Yep. So when we were sort of looking in terms of those your two sort of farm sites we did, you know, or actually these three, because we did one down at the lake there, we sort of had 4 good guys, you know, sort of things. We had the long fins, short fins, and then we had a migratory and a non-migratory sort of bully. So we had the Cran's bully and the common bully.
Oh yeah.
But then in this stream here, I think, even though it's quite small, we did I think we popped up, this is a site here, and we did have these little fellas, these
is that mosquito fish, and then that's carp?
Yeah, koi carp.
Yeah, which is
came cruising up.
Clay
You're
bottom.
trying to do a Craig to Free.
Yeah, I have seen them way up there over on the flats.
So I don't know whether they
they're not real big. The big ones can't get up. I don't think the big ones can get right up here, but I've seen smallish ones way up, which isn't a good thing.
And they don't muck around, and they sort of, because I mean, certainly in North Waikato, you know, the farmers, they just smash the banks or something.
Even they do. They get in, like, you'll scare them. Probably not here because it's not deep enough, but down a little bit they'll get in and they'll just wriggle in against the bank, and you can see just the sediment follow them. Or get washed away when they do it.
Yeah, they do a lot of damage ecologically. You know, in lakes they're like vacuum cleaners, hoover all the sediments and all that sort of thing, so they create turbidity, keep kicking nutrients up into the water column. So, you know, you'd know with Lake Naroto, you know, that there's occasional algal blooms. You know, that's partly because of, you know, agricultural catchment. There's a lot of nutrients in the system, but yeah, they also create problems when you're trying to actually re-establish, you know, aquatic plants in lakes, sort of thing. They just eat them all up, and then of course they also directly harass and compete with native fish too. So like I said, what I was telling you before, that the mosquito fish are apparently pretty aggressive, and they bloody nip eyes and nip fins on sort of native fish and all that sort of thing. So they can mean that you don't have if you're actually sort of trying to get new fish into your stream, if they can be sort of, you know, those sort of pest fish, you know, can be something that's also a barrier. It's not just about, even if you sort of plant this up and do things, you know, there's still those limitations about what we can sort of get up here if they're being limited.
Because if they're already here,
Yep.
That's the good thing about doing these EDNA samples, is that we've created a baseline, so we've seen what's in here at the moment.
Yep.
And we probably don't need to do it every year, but every maybe 3 years redo it and just see if we pick up anything new, like the kokopoo, which would be quite cool if we could. Then we can say that we're making progress, and you can visually see it. Like, that's what's cool about doing this.
Yep.
Yeah,
but
different times of year too, you know, to pick up those cycles when
Yeah.
they start moving.
Yeah. Thanks guys for coming out. That was awesome, and yeah, it was pretty cool to see these results. Hopefully you guys found it interesting too. I've got another kit here, so I'll put this in the next couple of months, so then I can see what we pick up in the summertime, because those last tests were during winter, see if anything changes. But it was pretty cool for them to make me up this, and if you want to go and have a look at my results, see that's Lake Naroto there, Ngaroto, and these are the sites which we tested at. So if you go to Wilder Lab, you should be able to explore, I think it is, I'll put a picture up what it looks like. Actually, that's what it will look like on the internet right there. That should pretty much wrap this video up, guys. That was awesome to get Craig out. He has very scientific answers, and it might take me a little bit of editing to cut it all down, but I'll see how I go. And other than that, see you next time.